Okay, let's do this. Start. Where did we reach? Unit 2. I think we'll finish this unit today.
What I want to do in this video is look at some examples of data represented in different ways and think about which representation is the best or can help us answer different questions. So we see this first example. A statistician recorded the length of each of Pixar's first 14 films. The statistician made a dot plot. Each dot is a film, a histogram, and a box plot to display the running time data. Which display could be used to find the median? All right, so let's look at these displays. So over here we see the 14. This is the dot plot. We have a dot for each of the 14 films. So one film had a running time of 81 minutes. We see that there. One film had a running time of 92. One had a running time of 93. We see one had a running time of 95. We see two had running times of 96 minutes, and so on and so forth. So I claim that I could use this to figure out the median because I could make a list of all of the running times of the films. I could order them, and then I could find the middle value. I could literally make a list. I could write down 81, and then write down 92, then write down 93, then write down 95. Then I could write down 96 twice, and then I could write down 98. Then I could write down 100. I see where you go. I think you see where this is going. I could write out the entire list, and then I could find the middle value. So the dot plot I could definitely use to find the median. Now what about the histogram? This is the histogram right over here. And the key here is for median, to figure out a median, I just need to figure out a list of numbers. I need to figure out a list of numbers. So here, I don't know, they say I have one film that's between 80 and 85, but I don't know its exact running time. Its running time might have been 81 minutes. Its running time might have been 84 minutes. So I don't know here. And so I can't really make a list of the running times of the films and find the middle value. So I don't think I'm going to be able to do it using the histogram. Now, with the box plot right over here, so I'm not going to click histogram. With the box plot over here, I might not be able to make a list of all the values, but the box plot explicitly tells us what the median is. This middle line in the middle of the box, that tells us the median is, what is this? This median is, if this is 100, this is 99. So this is 95, 96, 97, 98, 99. It explicitly tells us the median is 99. This is actually the easiest for calculating the median. So I'll go with the box plot. So the histogram is of no use to me if I want to calculate the median. Let's do a couple more of these. Nam owns a used car lot. He checked the odometers of the cars and recorded how far they had driven. He then created both a histogram and a box plot to display the same data. Both diagrams are shown below. Which display can be used to find how many vehicles had driven more than 200,000 kilometers? So how many vehicles had driven more than 200,000 kilometers? So it looks like here in this histogram, I have 3 vehicles that were between 200 and 250, and then I have 2 vehicles that are between 250 and 300. So it looks pretty clear that I have 5 vehicles, 3 that had a mileage between 200,000 and 250,000, and then I had 2 that had mileage between 250,000 and 300,000. So I'm able to answer the question. 5 vehicles had a mileage more than 200,000. And so I would say that the histogram is pretty useful. But let's verify that the box plot isn't so useful. So I want to know how many vehicles had a mileage more than 200,000. Well, I know that if I have a mileage more than 200,000, I'm going to be in the fourth quartile, but I don't know how many values I have sitting there in the fourth quartile just looking at this data over here. So that's not going to be useful for answering that question. Let's look at the second question. Which display can be used to find the median distance which display can be used to find that the median distance was approximately 140,000 kilometers? Well, to calculate the median, you essentially want to be able to list all of the numbers and then find the middle number. And over here, I can't list all of the numbers. I know that there's 3 values that are between 0 and 50,000 kilometers, but I don't know what they are. It could be 10,000, 10,000, 10,000. It could be 10,000, 15,000, and 40,000. I don't know what they are. And so if I can't list all of these things and put them in order, I really am going to have trouble finding the middle value. The middle value's going to be in this range right around here, but I don't know exactly what it's going to be. The histogram is not useful because it's throwing all the values into these buckets. While on the box plot, it directly tells me the median value. This line right over here, the middle of the box, this tells us the median value. And we see that the median value here, this is 140,000 kilometers, right? This is 100, 110, 120, 130, 140,000 kilometers is the median mileage for the cars. And so
Okay, let's practice. Which display can be used to find the maximum number of guests in a room? Histogram outside. No. Number of guests. The maximum number of guests in a room. 22. 22. He makes it clear that they were more rooms. With one guest. Which display can be used to find how many pumpkins is below 6? Histogram. Which display can be used to find the median mass? Say 8 kilogram. Box split. 8. Okay. It makes it easier to see that the third quarter is 14 degrees. And temperature in cats. Colorado for each of 30. We then create both. Display the same data. Third quarter is 14. Yes. What does that mean? What is the third quarter? It can be used to find how many days had high temperature below 8 degrees. But 3 days below 8. Right? It's 14 degrees. I don't know what this means. Third quarter. I got 2 days. What's the third quarter? What's the third quarter? 75th percentile of the data set. 5th percentile of the data set. So of the data line. That's more below this value. Go with the box. Both. To be honest, I would go with the box. The box plot. Because of this whole thing. Okay. Histogram can be used to find how many houses had areas greater than 200 square meters. This one. I could use both. Both of them. Okay.
What we're going to do in this video is start to compare distributions. So for example, here we have 2 distributions that show the various temperatures different cities get during the month of January. This is the distribution for Portland. For example, they get 8 days between 1 and 4 degrees Celsius. They get 12 days between 4 and 7 degrees Celsius, so forth and so on. And then this is the distribution for Minneapolis. Now, when we make these comparisons, what we're going to focus on is the center of the distributions to compare that, and also the spread. Sometimes people will talk about the variability of the distributions. And so these are the things that we're going to compare. And in making the comparison, we're actually just going to try to eyeball it. We're not going to try to pick a measure of central tendency, say the mean or the median, and then calculate precisely what those numbers are for these. We might want to do those if they're close, but if we can eyeball it, that would be even better. Similar for the spread and variability. In either of these cases, there are multiple measures in our statistical toolkit. Center, mean, median is valuable for the center. For spread variability, the range, the interquartile range, the mean absolute deviation, the standard deviation, these are all measures. But sometimes you can just kind of gauge it by looking. So in this first comparison, which distribution has a higher center, or are they comparable? Well, if you look at the distribution for Portland, the center of this distribution, let's say if we were to just think about the mean, although I think the mean and the median would be reasonably close right over here, it seems like it would be around 7, or maybe a little bit lower than 7. So it would be kind of in that range, maybe between 5 and 7 would be our central tendency, would be either our mean or our median. While for Minneapolis, it looks like our center is much closer to maybe -2 or -3 degrees Celsius. So here, even though we don't know precisely what the mean or the median is of each of these distributions, you can say that Portland distribution has a higher center, however you want to measure it, either mean or median. Now what about the spread or variability? Well, if you just superficially thought about range, you see here that there's nothing below 1 degree Celsius and nothing above 13. So you have about a 13-degree range at most right over here. In fact, what might be contributing to this first column might be a bunch of things at 3 degrees or even 3.9 degrees. And similarly, what's contributing to this last column might be a bunch of things at 10.1 degrees. But at most, you have a 12-degree range right over here. While over here, it looks like you have, well, it looks like it's approaching a 27-degree range. So based on that, and even if you just eyeball it, this is just, we're using the same scales for our horizontal axes here, the temperature axes, and this is just a much wider distribution than what you see over here. And so you would say that the Minneapolis distribution has more spread or higher spread or more variability. So higher spread right over here. Let's do another example, and we'll use a different representation for the data here. So we're told at the Olympic Games, many events have several rounds of competition. One of these events is the men's 100-meter backstroke. The upper dot plot shows the times in seconds of the top 8 finishers in the final round of the 2012 Olympics. So that's in green right over here, the final round. The lower dot plot shows the times of the same 8 swimmers, but in the semi-final round. So given these distributions, which one has a higher center? Well, once again, I mean, and here you can actually, it's a little bit easier to eyeball even what the median might be. The mean, I would probably have to do a little bit more mathematics. But let's say the median, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8 data points. So the median is going to sit between the lower 4 and the upper 4. So the central tendency right over here is, for the final round, looks like it's around 57.1 seconds, while especially if we think about the median, while the central tendency for the semifinal round, let's see, 1, 2, 3, 4, 5, 6, 7, 8, looks like it is right about there. So this is about 57, more than 57.3 seconds. So the semifinal round seems to have a higher central tendency, which is a little bit counterintuitive. You would expect the finalists to be running faster on average than the semifinalists, but that's not what this data is showing. So the semifinal round has higher center, higher center, and I just eyeballed the median, and I suspect that the mean would also be higher in this second distribution. And now what about variability? Well, once again, if you just looked at range, and these are both at the same scale, if you just visually look, the variability here, the range for the final round is larger than the range for the semifinal round. So you would say that the final round has higher variability. It has a higher range. Eyeballing it, it looks like it has a higher spread. And there's, of course, times where one distribution could have a higher range, but then it might have a lower standard deviation. For example, you could have data that's like, 2 data points that are really far apart, but then all of the other data just sits right. It's really, really closely packed. So for example, a distribution like this, and I'll draw the horizontal axis here just so you can imagine it as a distribution. A distribution like this might have a higher range but lower standard deviation than a distribution like this. I'm just drawing a very rough example. A distribution like this has a lower range, but actually might have a higher standard deviation. Might have a higher standard deviation than the one above it. In fact, I can make that even better. A distribution like this would have a lower range, but it would also have a higher standard deviation. So you can't just look at, it's not always the case that just by looking at one of these measures, the range or the standard deviation, you'll know for sure. But in cases like this, it's safe to say when you're looking at it by inspection that, look, this green, the final round data, does seem to have a higher range, higher variability, and so I'd feel pretty good at this. This is very high level comparison.
Okay. Practice that the greater median. what's cross counter crew. This is 75, which is easy to find. And here we got E4, 5, 6. Go 1, 2. So crew has a larger greater median. Crew has a greater standard deviation. From 120 to CA 10 to 80. Yep, cross. The following answers is true. Choose long jumpers. Octane is cool. The jumpers are very conservative. They are, which will result in a jump. As a result, similar short distances. Jump of 0 from similar short. At mid-end, are very aggressive. They jump as far as they risk faulting. About half the jumpers get a score of 0. And half jump long distance. Half jump long distance. Distance is about twice as far as a short distance. At Jefferson, the jumpers strike a balance. They are fairly aggressive, so careful. As a result, most jump medium distances between long distances and short, while one or two of them fault and jump 0. Then fault and jump 0. Standard deviation for jumps at Octane, the same as the standard deviation jumpers at Middleton. Nope. Octane. Nope. This is half. Nope. The mean jump at Octane is about the same as the mean jump at Middleton. Nope. The median jump at Jefferson is greater than jump at Octane. Yep. If 16 out of 12 Middleton jumpers fault, the median jump at Middleton is the median jump at Octane. If 6 out, that's half, jumpers fault, faulting. Half the jumpers get a score of 0. Half jump. So if 6 out of the 12 jumpers fault, the median jump Middleton is close to the median jump at Octane. I don't think so. As a result, they all jumps distances. What does zero mean? And what does fault mean? Six out is fault. In jump, it's close to the median jump. What does fault mean? Faulting no. Jump. What is this about? The long jumpers employ different strategies for competition. The jumpers what to get there. This specific attempt causes a foul overstep. When a long jumper faults, they get a penalty of failed attempt and no score or distance measured at turn. Stepping past the kickoff. So they always care on that, which could result in a jump of zero. What's a jump of zero? Jump of zero. Long jumpers get a score minimum. They receive no score, a foul, or scratch themselves. So arrow will result in a jump of zero. Result they all jump similar short distances. What does that mean? If 6 out of the 12 Middleton jumpers, are you a Middleton? Jump as far as they can, but they risk faulting. Score of zero, and have jump long distances. If 6 out is fault, the median jump at middle, close to the median jump at octane. Why? Oh, actually, octane doesn't say anything, which would result in a jump of 0. So very careful not to fault, which would result, but as a result they all jump similar short distances. But it doesn't say, so we don't know. Okay, the mean jump at Octane is about the same as the mean jump at Middleton, Octane and Middleton. This doesn't say. What does that mean? Jefferson, they are fairly aggressive. So careful. Median distance. So to most jump medium distance, long distance, while one or two of them fault and jump 0. So the mean jump at Octane, they jump as far. Think about a score and have jumped long distances. Long distance is as far as a short distance. Again, the standard dB for jumper at Octane is about the same as jumper at Middleton. Show a step actually. Possible for long jumpers are Octane, Middleton, 6, Jefferson. That's it. Octane. Not at all. Okay. The mean jump at Octane is the same as the mean jump at Middleton. Nope. Go, this is the mean. So this would be the mean. Is it here for this? I don't think so, no. I think, yeah, maybe, because 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, all 7. 2, 3, 4, 5, 6. 7. The mean jump at Octane is about the same as mean jump at Middleton. Octane and Middleton. No way. Really? Is it? One, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 16, 17. That's 11. 1, 2, 3, 4, 5, 6, 7. No. Jefferson is it? Is it the same? Yep, it's probably the same. 12 Middleton jumpers. Middle. Okay, Midlothian. 6 are fault. How many ones? 5, 6. They fault. Yep. The median jump at middle is close to the median jump at octa. 1, 2, 3, 4, 5, 6, 9, 10, 11, 13, 16, 17, 18, 19, 20, 22. 1, 2, 3, 5, 6, 7, 8, 9. Why do you say that that's close to this? Yeah. Nope. I don't get it. Get another. Spread the data on the mean. Therefore, middle is more spread out than for octa. Yep. What is that? It's about the same deviation for jumper. But it's not. What the fuck is wrong with you? There is no. So this is not it. Give more. Give another hint. All the octane, all the jumpers, short distance. So the mean must be a short distance. Half the jumpers are long distance. So the mean is the average of a long distance. 0. Suppose 0. A long distance, short distance, about the same. Then all the jumpers are short distance. So the mean must be a short distance. Middleton, half the jumpers, 0, and half the jumpers are long distances. So the mean is the average of a long distance and 0. Over 2 is a short distance. What is? Octane and Middleton. Every other means should be about the same. Octane at Middleton. Octane. Okay. What else? The mean. The 6 out of its fault. Out of exactly half the middle long and half will be 0. Middleton jump the average of a long jump, 0 minus a short jump. Since all jumps at octane are short, the median must be short value. The medians will be closer to octane. Right? Out of the 12 middle jumps, the median jump at middle is close to the median jump at octane. Octane قلنا short. And this here octane is short and this will be short. God damn it. Okay. To octane, the median jump will likely be less equal the mean the median, the mean. Oh my god. Are you sure that I should know? As a result, they all jump somewhere short distances. Short distances. Yes, equal, but median is the middle value in a data set. So higher how to find the median, pull all the numbers that from least to greatest, pick the single middle number, even amount, add the two middle numbers and divide by 2. Add the two middle, divide by 2. Stupid of it. Type the mean. Intention or the set of number and dividing by how many numbers are there. So 12 over 12 is 1. Calculate by adding a set of numbers, dividing by how many numbers are there. Say they all get short, divided by 12, give it 3. 3. They all get 3. 3 over 12 and 3 and 3. Right. So what do you say? The median 3 plus 3 equals 6 over 2 or 3. And the mean, well, the mean is going to be 3 to the power of 12. 12. Right. 1. That's multiplication. 3. Yep, it's gonna be equal. Yep, it's gonna be equal because 3 plus 3. Yep. Okay. Suppose 7 out of 15 jumpers faulted at Middleton. At Middleton, the median jump will be the median jump will be the mean 7 to 15 jumpers. 7 out of 15 jumpers, which means that the mean is, like we said, the eighth. No, 8 and 8, 16. I know 18, 8 and 8, and 16. 15 jumpers, what's half of 15? 7 and a half. 7 and a half. It's odd. So I got to take the middle. 15 over 2. 7 and a half. What's 7 and a half gonna be? The middle one. I would say middle two. The jumpers are jump far as they can, but they risk fault. Half the jumpers get a score of 0. Half jump longless. Score of 0. Distance is about twice as far as short distance. So the median is going to be 7 and a half. Okay? Where the mean I don't think so. 7 and a half. And the mean is going to be, they get less than the mean. Yep, less than the mean. At Jefferson, the median jump will likely be Jefferson jumpers. They are fairly aggressive. The result most jump medium distances, while 1 or 2 of them fault and jump 0. So I got 2 0 and 10 and 10 ones. 10 ones, let's say long are twice, which is 2, and the medium is 1, so I got the medium will be -1 minus So this the median likely the median jumper likely be less equal the mean. What do you mean equal the mean? I got two faults. And the mean is, like we said, you take them all and divide them by how many? 12. So you get 10 over 12, while the median is equal. Hence, no hints, give hints. Correct answer is equal. Larger than the mean. What did we say? Less than the mean. Less than the mean. Be the larger than the mean. Tell me why. Shouldn't this leave the mean be greater than the mean? 17 are faulted, slightly more than half of the jumpers. What do you mean? Slightly less. More than half jumper will hit long distance. More than half. That's true. Right. Hit long. So the median will be long distance. The mean, however, reaches the 7 scores of 0 and the 8 long distances mean will be the middle of distance 0. The median, so this is the mean, while the median, the long distance. Is one of these medium distances, but there are a couple. These are for the mean but not affect the median. Very much the mean is long. Okay. And you want to see how long capacity varies among endurance enthusiasts and both. The difference between its is the mean. Team has a greater difference between its mean and median. We said its outlier 30 and 40 and 50, 30 and 40, whatever. So this means that the mean is gonna be as greater than its mean and mean. Oh my god. I would say cross counting. There's no outliers here. Cross counting has a greater in quartile range. 20, 110. This is 1, 2. Three quarters. Three quarters is incorrect, so we're at 120. And here 2, 3, say 1, 2, 7, 1, 2, 3, 5, 6, 6 and 7. That's 13. 1, 2, 3, 4. Got 9 here. 13. So still cross counting. Let's do it again. God damn it. Would this be useful for a machine learning? I have no idea. Okay. Big games. Other big games, many events have several. Where's the center of the semi-final round distribution is at the center of final round distribution. Final round, semi-final. Distribution is greater. I don't understand this. It's final round. Distribution. The semi-final distribution. Distribution is less than about the same as the center of the round. How is this related? The distribution and the center. What does that mean? The center, the mean. About the same. In the center, the distribution is actually, I got 4 columns, and here I got 3's. The center is this. Go with greater. The variability in the semi distribution is greater in the final distribution. This I'm sure of, but this, the center, in the center we got the median and the mean. So the center is about half. Yep. It's about the same. Center of the same distribution. How is that? Times and seconds of 2/8 finishes and times of the 8 minutes. So this is the times 53. What does that mean? 53. 8. 53. 8 is 3 seconds. So this is what it actually is. Let's see if the distribution is like this. So I got final and round. I'm reading it the wrong way. So actually is less than, because this here it's 4. This is, so I got here it starts from 52 to 3, here it starts from 52.7. The distribution here is greater, but here the center same as, I don't think so. The final round is still larger. The center would be here. No, the center is 53, is larger in the semi-final. It's greater than. Okay. Fill in the blanket. The center of the US qualifier. Fusion. The US qualifier. The Olympics. Olympic distribution is less than. the mean and the variability in the US qualified distribution. This qualified distribution is also less than the variable. Here we got it varies. So okay, center of the marble comics distribution, the center of the X comics distribution. The X comics marble comics distribution, center of the DX 7. Marble center is greater, I would say. Can't get the center here, but it's greater definitely. Movies. It's greater outgo. Variability. Also greater from 0 to 7. Also greater. I would go okay. This varies, whereas the center is less. So the center of Olympic distribution is larger, greater than, and the variability is less. It's less. This is scattered. Okay. This varies more, and the center also is larger. So basketball, center of basketball is larger, and the variability of the basketball is greater because it's scattered. Why? Okay, so variability and the center both are larger than 2015, so less. Fusion. So the center would actually be larger here in Portland, is less than, and the variability in Minneapolis is greater. God damn it. The center, I got 21, 36. The center must be here, somewhere 27. Here I got 15 and 36. What are we talking? The variability, I got 15 to 36. So this is greater. The center of Portland. Portland, I said the center must be larger. Here 15 to 36. Got no other answer than this. What are we taking? Number of days, temperature. get the center. Because the mean is going to be way less because of the median. Seriously? It's distribution. Center. What about the outlier? Last question. Distribution here is larger and the center here is larger. Center distribution is more. So what is this? Alabama. Center is less in the empty distribution. Is less. Quiz 2? I don't think so. I think we'll leave this for tomorrow. It's 26 out of. Okay. Nope. This is tomorrow. Unit 2. Start quiz. Start unit test. Okay, this is tomorrow. Okay.